Okay, so yesterday we talked about the properties of the laser, how it basically work. Then we have seen the monochromaticity, coherency, and the collimating behavior. Then we talked about the um, temporal coherence and the spatial coherence. So today we are going to discuss about the type of the lasers. So this is a solid state laser. uh, Here you can see that this is solid state laser which use basically solid state means made up of the molecular crystal. So it will have the ruby laser, suppose made up of the crystal, then neodymium YAG laser. Okay, and also where it basically used. So here you can see that this Luby razor were used in the medical application, such as in a dermatologist are making the tattoos, okay, are also for removing the tattoos as well as the retinal surgery. Okay. Yeah, as well as the retinal surgery. So what basically happened in this thing? What kind of the basically material we use? Have you heard seen the periodic table in the chemistry where hydrogen, helium, lithium, niobium? So that all element exist. So basically for the laser to undergo, what's important is the transition. Okay, so ion, the transition element basically undergo a number of the transitions from s, p, d, f orbital. So the most of the things that we use is the rare earth metal, the neodymium, ytterbium, erbium, holmium, etc. Okay, these are rare earth element, but it has a very high transitioning property, as well as the transition metals such as chromium and titanium. They are commonly used as a dopant. Okay, and the host material means the bare material that basically used in the solid state laser is the aluminum, alumina, YLF, that is ytterbium, lithium, tetrafluoro and tetrafluoride. Okay, so YAG, what is YAG? YAG is basically 3 is to of the ytterbium, 5 ratio of the aluminum, and 12 ratio of the oxygen. Okay, so this is how basically this compound and this neodymium ratio combined, and we were able to make this kind of the crystal, and this kind of the crystal basically used in our medicinal purpose. Okay, so next, as we are using the laser, so we need to avoid the precautions. What are the precautions we have to take? That is very important. And also the laser, what is exposing is not only of one type. Okay, it has different energy. So here you can see that it has a energy, different energy of 0.1 milliwatt, 1 to 5 milliwatt, 5 to 500 milliwatt, and it come in different categories. So some classes, so 1m class, 2m class, based on their power energy sources. Okay, so what are the hazards that can be occur using different power laser, different type of the power laser. So typically when laser is not accessible, non-hazardous to eye, hazardous with collecting optics. So if you are taking 0 to 1 milliwatt, okay, so hazardous only when person overcome aversion response. Okay, so what basically happen simply, if you are directly using the laser, and if somehow it will come to your eye contact or on your skin, if you are using very high power source, then it can damage your skin as well as the eye also. So we have to always wear wear specs, so that it will not the laser light will not transfer directly to your eyes. Okay, so also here you can see that the class 2, class 3 are 3V, 4 and class 4 laser. So it has a different wave distance. Eye hazardous distance or nominal occur hazardous distance, that we call as a NOHD. It is something biology related because the laser use mostly frequently we used in medicinal purpose. So we should know that what's the hazardous distance, at what distance we can the laser can impact our skins and the eye. Okay, so different kind of the classes is divided into the different length, different blindness distance, and also the skin burning distance and the fire hazard distance. Okay, so these all are not as important, but if anyone is using particularly the laser for some treatment, they always get to know that what is the possible mm, distance where the eye start can burning, or it can impact our skins. Okay, so this is very important, and this should always keep in front of the door where basically the laser kind of the things we instrument are present there. Okay, so next is the topic which was present in your syllabus is the focal length of the laser lens. So I hope you people will understand, because I in the optics chapter you have studied about the what's the focal length. So here we are understanding the laser lens focal length. Okay, so as we know that the laser which are passing, it will have the parallel beam of the light, but we use collimated lens so that it make it parallel. Okay, and once it is for focusing means converging lens, if you are using, then it will converge it at one point. That point, the distance from the converging lens to the um, focal spot size at the point is defined as the focal length. Okay, and at what area that spot has formed, that is called the focal spot size. Okay, now the two important things, the depth of the focus and the focal length, which we will study in the next slide. Okay, so this is basically simple thing. What's the focal length? From the distance from the collimated lens to the to the focal spot size. Okay, so where basically this lens are present in the laser. Okay, so in this figure you can see that you have a laser where it has a pumping source, lasing medium, that only ruby crystal and neodymium YAG laser. Okay, and it is covered with the optical cavity, and it has a reflecting surface. So once the laser is coming parallel beam of the light, it has converging lens. That converging lens making it in a to converge it at one point, and the distance from this length is defined as the focal length or focal beam or minimum spot size. Okay, so what's the focal length? Focal length of the laser refers to the distance from the lens at which the laser beam converts it to the smallest possible spot. Now the thing is, what are the common focal length? Okay, so the value of this focal length basically depend upon what kind of lens we are using, what is its curvature, and what's the refractive index of the lens. So question may asked that what on what factor the focal length of the laser depend upon. So you have to answer the type of the lens, the curvature, and the refractive index of the lens material. Now, what are the common focal length according to numerical value? So, short focal length basically has a 25 millimeter to 38.1 millimeter, okay, and 50.28 millimeter, that much only. So, what short focal length give you? It basically provide you smaller spot size with high resolution and short depth of the focus. Okay, short depth of the focus and ideal for fine engraving or cutting the thin material. Okay, so if you have to cut anything, then you can use the short focal length of the laser. Okay, now what a long focal length has a wider distance, you can see 63.5, 76.2 millimeter. Okay, and what it basically produce, it will produce larger spot size and have longer depth of focus. So what is basically depth of focus? Next slide we will do. Then better for cutting the thicker material are whether consisting over depth. If you have to cut very fine structure, then you should use short focal length. But if you have to use a thicker material, then you can use your long focal length of the mirror. Okay, so next so what is basically this depth of the focus? So here I have put the definition here. The focal length, as we have seen, the distance from the lens to the center of the point where parallel ray of the light is converging after passing through the lens. Then what is focal plane? Okay, focal plane is nothing else. Here you will have the perpendicular plane. Okay, so you can see that this is a lens. After converging, you will have the plane perpendicular to the optical axis of the lens or mirror, and it is passing through the focal point. Okay, and now what is the depth of the focus? So the depth of focus or the focal depth is the range of the distance for which specimen is imaged with an acceptable sharpness on the image plane. Okay, sharpness of the image plane. Basically, it will depth of focus give you the information about the resolution of the images. Okay, how much resolution you want, it depend upon what is your depth of the focus. Okay, so here you can see the example that here some DOF, yes, depth of focus they have determined by the optical range. So they have used the aperture size, lens aperture size is 100 micrometer. This is 100 micrometer. This is 200 micrometer. Okay, so you can see aperture. This is aperture. That is only the lens. Okay, so it has a bigger opening. Okay, so it has a smaller opening. This is having a bigger opening. So once the light is passing, it will converge and will make a up to this distance. It will get coincide. Okay, so depth of focus is a very small. But if you have a smaller aperture, you can see that the depth of focus is more deeper. Up to this much distance you can see. Okay, so smaller aperture or a smaller opening will give you larger or the deeper depth of focus, and a larger aperture angle will give you a smaller depth of the focus. So magnification basically, where the magnification will be higher, where the depth of the focus will be depth of the focus will be shallow. Okay, means it will not be a deep. So, and if the depth of the focus is deep, then the magnification will be lower. Okay, so this has to understand. So magnification is basically inversely proportional to the depth of the focus. So the magnification means like how much you can magnify your images. So magnification is is inversely proportional to the depth of the focus. If your depth of the focus is deeper, then your magnification will be lower. Okay, and if your depth of the focus is smaller, means shallow, then magnification will be higher. Okay, this is all about the depth of the focus. It is important when you are doing basically the imaging process. Suppose in SEM, I think you have heard. Can anyone tell me what is SEM instrument? Can anyone tell me what is SEM instrument? Anyone can tell. Have you heard of electron microscopy? Have you heard of AFM? AFM? Huh?
No,
Sorry, I did not get it.
no, ma'am, I've not heard of it.
Okay, okay, no problem. Maybe you will read a letter. So SEM is basically a scanning electron microscopy. Okay, and there is, it's a microscope. So a normal microscope, what we do, we magnify our image. Now, so in optical microscopy, atomic force microscopy, scanning electron microscopy, you will not able to see the images from the bare eye. That using that instrument, you can able to see the resolution. So basically for SEM, the resolution is like 1 micrometer. You can zoom your images up to 1 micrometer. Okay. But if you're taking AFM, atomic force microscopy, so that in that instrument, you can able to zoom it your images up to 1 nanometer. Okay, so these all are very powerful instrument and mostly used in the material where the material research basically occur. Even I also used in my research purpose the SEM, AFM, TEM, transmission electron microscopy. I think you will heard later, but this is all about the microscopy in SEM. Basically, we use there will be a two type of the objective lens, the smaller and the larger aperture angle, and it will give you the different depth of the focus, deeper and the shallower. Okay. So now next is yeah, now it is coming to the with the biology. The physics is now coming and incorporating into the biology. So basically biology, if you talk about, first thing will come is the tissue. Okay. So here we are going to read about the laser. This is the laser and interaction with the tissue. Okay. So this is like little bit theoretical part we can say, because in bio you have to learn a more. Okay, and there is a lot of concept, but still I will try to make it as easy as I can. Okay. Uh, so here what is the things once your laser interact with biological tissue. So what the interaction cause? So there are four primary interaction it cause. First is the reflection. Is it is just simple. Whenever your any of the light incident on your material, what basically happen is the reflection, absorption, transmission, and scattering. Okay, so these are I think you have heard it. So similarly, here in the biological tissue also the same procedure occur. So what basically they affect? So first, once it is coming reflection, means nothing is going inside. You can see the first one. Okay, this first one is undergoing reflection. That why the reflection happen? Okay, because it does not have that much intensity to penetrate the tissue. So when the reflection, what reflection affect, it is affected by, so may why it does not penetrate? Maybe your skin texture was different, or you had very high surface roughness, or the angle of incident was not correct. Okay, so this can might be the possibility when your laser is reflecting when it is interacting with the tissue. Okay. Now the second case is the absorbed by the tissue component. So when it will absorb by the tissue component, so here you can see some of the light has got absorbed. So the absorption basically occur because of the like melanin, hemoglobin, and the water. So light is absorbed by the tissue component. So what are the tissue component we can say is the melanin, hemoglobin, and the water. Okay, these are the component that is responsible for the absorption of the light. Now the third. So, but here also the most critical interaction that arise is if it is absorbing, might be possibility that it can cause heating. Okay, so it can cause heating or some reaction can also undergo. Why? Because when you are heating your light, maybe the hemoglobin, it has iron containing metal complex. Melanin also have some metal complex. So these can undergo in the presence of the light some photochemical reactions. Okay, are the fluorescence. Also, it can enable the tissue ablation, coagulation, and stimulation. This we will study in next slide. So, what is basically ablation, coagulation? Okay, that we will study in the next slide. So, basically, this kind of absorption is important. The proper interaction with the laser tissue is the starting from the absorption process. Okay. Now the third is the transmission. Transmitted light means it will pass through your tissue. It will basically pass out through your tissue. When it will happen? When you will have a deeper tissue. So these kind of the light basically, if it is passing throughout your tissue, that means it is affecting your deeper tissues. Okay, you can penetrate to the deeper tissue, and also it can cause unintended effect. If you are not careful, then it can cause damage to your inner tissue liner. Okay. Also, if you're scattering, when the scattering occur, scattering means your mm, your light is penetrating inside, but inside only it is undergoing scattering. So when it basically occur, when you will have the tissue having the structural discontinued, the structural uh, what to say, structural inhomogeneity. If you will have the structural inhomogeneity, then the scattering event occur, and also it basically reduce the resolution in the imaging and contribute diffuse heating. If it is diverting, then what it is causing is basically the diffuse heating. Okay, so these are the process, initial process when the laser is interacting with your tissue. The reflection, absorption, transmission and the scattering, and they all have a different uh, mm, uh, limitation, why it basically occur and what precaution we can take it. Okay, now the thing is next. Yeah, so I was talking about you when your laser light is absorbing. So what can be the possible things? The ablation, coagulation, and the stimulation, right? So this is the cross-sectional view of how your laser energy affect the biological tissue. So you can see this is the tissue surface. Okay, and this is the light you are irradiating. Okay, so what are the factor basically affect your laser tissue interaction? This might can ask in the question, in the what to say, in the examination, that what are the factors that can affect the laser tissue interaction. So first is the wavelength, power density, tissue characteristic, exposure time. Okay, so here first we are talking about this irradiated volume. Okay, so this irradiated volume depend upon your wavelength, power density, tissue characteristic, and the exposure time. Okay, so here you can see what's wavelength will determine. It will determine your penetration depth, different tissue that absorb different wavelength. Okay, power density means how much energy per unit area it is influencing and how intense the effect is. Then tissue characteristic, what kind of the tissue characteristic you have. So here you can see this is the tissue characteristic, exposure time, wavelength. So tissue characteristic means water contained pigmentation, whether it is dry or pigmentation or vascularity is there. Okay. Then exposure time, how long you are exposing and increasing it can increase your tissue damage. Okay. So now the next, so these all are about how, on what factor this laser tissue interaction depend upon. So you have to you have to learn carefully that it depend upon wavelength, power density, tissue characteristic, as well as the exposure time. Okay. So next, the bottom section. This is the bottom section, the zone created in the tissue. So what are the zone? You have a tissue surface. Next is the volume of the cut, area of coagulation, and area of edema. So what is this thing? So it is divided into zone. Okay, one is central zone, middle zone, outer zone. So this part is the central zone. Red part is the middle zone, and this green part are whatever color it is, this is outer zone. Okay, so what basically this central zone cause? So this is a light red area. This is where laser energy is most intense. Here the laser energy will be most intense, and tissue basically ablated or vaporized. Vaporized or ablation means that there the tissue will remove. Okay, or it will cut off, or you are just cutting the tissue layer. Okay, the are simple, the vaporization of that area will occur. Okay, why? Because your laser intensity will be very high. Then in the second middle zone, dark red area, what will happen is that once the laser is passing through the second layer area, what it will cause? It will cause the heating. So heat, because of the heating, your blood will start getting coagulate. So coagulated protein basically will form, and that can seal the blood vessels or stop the bleeding process. Okay. Now third, the outer zone. This is the outer zone area. So greenish blue area it is. So what it will do? The surrounding tissue becomes swollen. Okay, because of the heating, it will get swell, and it will not have enough to cause the cutting or the coagulation. So basically the thermal spread basically occur. Okay, so this is called the area of the edema. Edema is basically nothing else where because of the heat or the diffusion, you will have the swollen area due to the coagulation. Okay. So these are the bottom section created once your laser is interacting with the tissue. Okay. So this is now what's the chemical reaction we have studied that it can undergo the chemical reactions also. So once it is getting reaction, so there are five steps that basically occur. First, we already saw the ablated region where the vaporization of the tissues occur. Then carbonization. Then here again vaporization occur, coagulation and hyperthermia. Okay, so what this is the laser induced photothermal reactions. So photothermal reactions basically occur. Ablated area, tissue is completely removed. What it causes? Extreme high energy density cause the tissue to get breakdown because of high intense. Where we can use this thing? We can use in cutting procedure, tumor. If anybody is having tumor, that to remove that we can use this laser. Then LASIK, cornea reshaping. In eye we have a cornea. Okay, so if you have to reshape your cornea, there also you can use the laser. Then second process is the carbonization. Carbonization is what happened? Carbon means, carbonization means carbon. So tissue is basically burned out, and because of burning it will get black, because our body is also made up of the carbon only now. So whenever it will get burned out, it will become black. Okay, and due to that it will cause the heating. It causes the heating, but material will be remain same. So what concern we can take? We have to limit the intensity of the laser light. Okay, so heat based reaction basically caused by absorbed laser energy. Okay, so now next is the vaporization. Okay, so vaporization when happen when you will have the water some containing or melanin or the hemoglobin, some liquid thing. So what will happen? It will start boiling and it will get evaporate and cause the tissue interaction. Then if you will have high heat, it will localized to the water containing structure. Where the what is the application of this thing? Application you can use in the tissue shrinkage, volume reduction in cosmetic. Okay, then the fourth procedure is the coagulation. Coagulation means like a solidifying your blood. Okay, blood, protein are tissues. Okay, so protein in the tissue denature and solidify, sealing the vessel. So the moderate heat that require is 60 to 100. Okay, so where application? Hemostasis, that we will study later. Okay, then hyperthermia. Hyperthermia is nothing else. You will have here very mild heating which cause biological effect without visible damage. Okay, so this kind of the hyperthermia is used in the cancer therapy. Okay, and laser physiotherapy. So these all are steps basically occur when any of the photothermal effect is happening with the laser and the tissue interaction. Okay, these all are new word for you. For me also it was very new word. Okay, but the thing is here they have explained stepwise how the process occurring. So it is basically easy for us to understand. Otherwise, it is very difficult sometime. Okay. Yeah. So now the next is yes. So this is the energy source that interact with the tissue. This is just a conclusive slide. What basically happened? So we have seen that interaction with the tissue basically depend upon the optical properties, absorption process, thermal property. Okay, and then these optical property is depending upon how the light distributed, and if the light is distributing, then what's the reaction is occurring? Photochemical reactions are then also if absorption is occurring, then heat also will generate. So where we can use this thing in the therapy or in the diagnosis, this is the precure things that we can use it. And then if thermal properties is coming into picture, then heat conduction, then we can also perform thermomechanical effect using a therapy treatment. Okay, so these are nothing else, just showing a conclusive slide. What can be the possible ways where the laser can interact with the tissue. Okay, so it affects how light is distributed and also determine the rate of the heat generation and affect the heat conduction. So tissue changes from excess heating, damaging the effects. Okay, so next here. Yes, you can see here in the images this laser where you can use it. I think the laser eye surgery you have already heard of. Okay, many people used to do eye surgery to change the color of the eye. So from blackish to the different color, like nowadays it is so much people are doing, especially Bollywood. In the Bollywood, like from black to brown, brown to green, something. Okay, so it's like a laser surgery they are doing. And other thing you can use in the dermatologist also, like plastic surgery. Have you heard of plastic surgery also? So laser treatment for the pigmentation. If you have scars, pimples, if you have to remove that also permanently, in that also you can use laser. Okay, so also in the imaging process, so if you have to see inside body structural feature, so in that case also imaging laser used. Okay, so these are the applications where medicine, in the medicinal field you have very lot of application regarding the lasers. Okay, but what kind of the laser you have to use, it depend upon the treatment. Okay, so what laser is used in laser tissue interaction, that same I told you, neodymium CO2 laser, and erbium YAG laser, argon laser. So these four kind of the laser is very important, which has mentioned in your syllabus also. So I we will read it in detail about these all laser. Okay, so how it work, what are the principle? It so erbium YAG laser or the chromium YAG laser, it comes work in the contact mode lens, sorry, in the contact when the laser is in contact with the tissue. And CO2 laser work when it is in non-contact with the tissue. Why it is non-contact? Maybe it has higher intensity as compared to the RBM YAG laser. And then diode neodymium YAG laser, when you will have the contact also, and it cause the different procedure. Okay, so this is a different procedure occur in CO2 non-contact procedure, in the RBM YAG and diode neodymium YAG laser contact and the contact procedure occur. Okay, so now we will move on to first laser, which has been mentioned in your syllabus, is the basic principle of the neodymium YAG laser. Okay, so neodymium YAG laser basically made up of the neodymium, and it is a rare earth element, and YAG is basically yttrium, aluminium, garnet. Okay, so it will be yttrium element, aluminium, and the garnet, which has a ratio of 3 is to 15 is to 12, and it works on what type of the laser, that is that we have studied in the first class, two label, three label laser, four label laser. So it basically work on the principle of four label laser. So here the schematic you can see, the solid laser which we are using is the neodymium YAG laser. You have the same, other things are same, rear mirror output, and then collimated lens that will uh, undergo the focusing of your laser beam, and then it basically work, this is the basically principle of the schematic of the neodymium YAG laser. So what is the principle? So active medium is the neodymium YAG rod laser. Okay, so what happened in that? What happened? Your neodymium ions and neodymium convert into 3 plus oxidation state. Okay, and once it is converting into 3 plus oxidation state, when you will have the transition from ground to the excited state, and during the transition from during the transition, after that it will go undergo de-excitation to metastable state, to the ground state. So the laser beam will emit the light photon, and that photon will have the wavelength of 1.064 micrometer. Okay, so this is the principle of the neodymium YAG laser, and this laser basically generate and has a wavelength range in the form of near infrared region, and also it emits the light in several different wavelengths such as 1440 nanometer, 100, 1320 nanometer. These are the different ranges of the wavelength. Also, you can perform this kind of laser. Okay. Now the thing is, the construction of the laser. So same whatever I have told you, you will have the ytterbium, a small amount of ytterbium is replaced with neodymium in the active medium. That's why you will have the combination of the neodymium as well as yttrium, yttrium, aluminium, garnite rod. Okay, and this is the active medium which present in the form of cylindrical rod, and the end of the rod are highly polished and optical flat. Okay, and it undergo the pumping by applying the external source to it, and it undergo the excitation. Okay, so two reflecting mirror are also there. So it is the same procedure how it basically work. So simple, the laser, the neodymium are excited from ground state E0 to the upper state E3, E4. Why E3? Because neodymium is directly converting into the 3 plus oxidation state and then going E4 to the pumping. As we are doing the pumping, so due to the absorption of light radiation, it will have wavelength of 0.73. Then it will excited level, uh, then it undergo de-excitation to E2 level. That E2 is called metastable state. And then the collection of the energy occur from the E2, and because of the population inversion, the electrons basically de-excite to the E1 state and emit the photon in the form of the h nu. Okay, so this is simple how the laser principle work. Okay, so you can see from the figure also here, from E0 to E3 state, and then E3 we are pumping to E4 state because four label laser it is. And then we are de-exciting to the E2. This E2 label is the metastable state. Then it is going to the ground state. Once it is going to the ground state, it will emit the laser, and this laser will have the wavelength of 1.06 micrometer, which comes in the range of the infrared light. Okay, so this is the procedure or the transition occur in neodymium YAG laser. Okay, simple. Now the thing is characteristic. Characteristic is also same. You will have E1, E2, E3, E4 labels. Active medium is your rod, and pumping is the optical pumping, and pumping source that we are using is the krypton flask tube. And then our power output, whatever the power output we are getting is 20 kilowatt. Okay, it is very much high. And then what is the output, whether it is a continuous wave or the pulse. So it depend upon uh, what what kind of the light is emitting. Okay, then wavelength of the output is 1.06 micrometer infrared. Okay, now this is the also a schematic with the electronic transition. Here you can see that simple. You focus on this step. You are incidenting the photon. Photon incidented. What happened directly? Three of the electron went to the E4 state. So here you will have now six electron. Then what happened is that it comes down to the E3 state. All four electron. So now it has a population inversion. On the excited state, you have higher electron as compared to the lower state, that is E2 and the E1. So now what will happen is that one electron undergo another de-excitation to the E2 state and emit the photon. Okay, so now it, as it has emitted the photon, this photon now undergo emission, hit this another electrons, and these electron now undergo de-excitation. So more de-excitation occur, three de-excitation, so it will emit another photon. So like this, all the population, all the electrons which are present at a higher energy level undergo population inversion and emit the two photon, three photon, five photon, like that. And in this way, the increase in the intensity of the light occur. So the energy level which will have higher, E1 will have lower, and E4 will always have higher. And when you are talking about population, so population wise, N1, N2, N3, N4 will have higher. Okay, so here you can see, here you have a 4, you sorry, here you have 6, here you have 5, here you have 4, here you have 3. Okay, so that is the number of the population, means number of the electrons. Okay, this is the procedure. Okay, now the advantage. What are the advantage? Advantage of this laser? Basically, this is the laser figure in the figure it is imaging, shows this kind of a green emission of the laser light. So it has the advantage is that low power consumption, and also uh, the low power consumption it has, and laser offer high gain, good thermal property as well as the mechanical property, and also the efficiency of this laser is very high as compared to the ruby laser. Okay. So these are the advantages. These all question can be asked in your examination once you will your professor will take your the classes, our examination will occur. Okay. So this slides is in it itself is very important. Okay. So what is the time now? 7:20, no? Mm. We have 15 minutes more. So what is carbon dioxide laser? This is another laser which we are talking about. A laser that use the carbon dioxide as a gain medium. Means here carbon dioxide is present in the form of gases. Okay. So what carbon dioxide contain other than CO2? You have N2, nitrogen, helium, hydrogen, water, oxygen, xenon can also be added to improve the performance. Okay. So what's the function? What is the function is that the laser function through an electric gas discharge which stimulate the gas mixture, result in the laser light production. So it is the best laser I will suggest are according to me. Why? Because it is the best utilization of your CO2 gas. Okay, which is a greenhouse gas and cause the increase in the temperature, global warming. Okay. So in carbon dioxide laser, the electric gas discharge can powered by AC. So basically CO2 we convert this gas discharge occur because of the AC. We apply AC voltage and the DC current are the radio frequency energy. Okay. Here you can see in the figure also laser beam output, stimulated emission, active medium, inside your laser is there. Okay. So these laser will basically have a 10.6 micrometer which is higher wavelength than the neodymium YAG laser. Okay, where you can use in the dermatologist, scar removal, wrinkles which we have seen in the pictures also we can apply in the surgical applications such as gynecologist, neurosurgeon, or accurate cutting and tissue removal. Okay. So what is the working principle of this CO2 laser? So this is the construction of your CO2 laser. You can see here the gas laser basically here inserted to generate the laser beam, laser gas for the generator. And here you will have a pumping source which is connected. Okay. So here it is just construction. Inside this we will go in next slide we will see. So it is a sealed optical path and you will have the reflecting mirror. Okay. You have a reflecting mirror, beam protection box, assist with the cutting gas. So these ray pass through this, then reflect to this side, then it will pass out, come out from the beam protection box, then undergo the collimation and the focal length produce. Okay, so these all mirror consist of silver coating so that it will be more reflecting, and used in the zinc selenide component or gold coated mirror basically we can use it. Okay, now how it basically work. So here you can see the picture. Okay, so how the gas insert. So gas pipeline, have you seen somewhere that you if you have to pause different gases, gas pipeline will be there. So it is just similar to that. You can see in the figure also you have a different inlet outlet. Okay, so through the inlet you will you can say that this is a gas circulation system. So these gas circulation system consist of the CO2, nitrogen and helium, and remove the spent laser and proper gas flowing maintained here. So rear mirror laser beam is there, output mirror and DC excited discharge is there. Okay. So these are the picture which is showing how the gas is going. So gas outlet, gas inlet. Inlet means where it has to go. Outlet means when you see that your gas is more inside the tube, then what you will do, you will outlet your gas and it decrease the um, volume of the gas mixture. Okay, so what basically inserted into and what's the ratio? So carbon dioxide laser basically centered around quartz discharge tube, and it will have typically 2.5 centimeter in diameter. These are the diameter is 2.5 centimeter. And also CO2, nitrogen and helium will have a mixture of 1 is to 2 is to 3 ratio. Okay, and some amount of the pressures that we can add is the 7 torr, 1.2 torr. These all are the gases pressure added when you have to go inside into the lasers. Okay, so now the thing is, the first things, the laser beam, basically having 10.6 micrometer infrared light. Then output mirror is there and rear mirror is there. What is the use of them? They are acting as an optical resonator, जो कि no, whatever it will do is the reflective. It will be reflective. Output mirror is partially reflected light to escape as the laser beam. Then excited source where the CO2 will get discharged. The active medium CO2 gas energized using DC component and excite the gas molecule. Once your gas molecule undergo excitation, what will happen? Your population inversion will come. Okay, so the population inversion will start because ground to the excited state, the DC current basically helping in to undergo the excitation of your CO2 molecule. So once it will get excited, it will cause the population inversion. Okay. So these are the component. Fold mirror is also used here. This the at the other end. This is the fold mirror. You can see they have used the extend the optical path without requiring a physical longer. It has a this component basically designed for higher gain and power within a smaller footprint. Then gas inlet and outlet. To introduce a gas mixture CO2 N2 and remove the spent glass. Proper gas flow is important for the laser efficiency to get maintained. Okay. Now next how it basically works, same, the gas will basically flow it, then electrical excitation occur, then population inversion, then laser action and laser beam output forms. Okay, so this is the transition basically forms where you have a ground state, then excitation occur. So first what happen is that we introduce nitrogen. Okay, we add some mixture of the nitrogen also. So electric discharge facilitate the population inversion CO2 molecule, and this CO2 molecule will coincide and boost the CO2 molecule to undergo higher energy state. So what happens is that electric discharge inside the apparatus cause electron to collide with the nitrogen molecule. So once your nitrogen is colliding with the electron, what will happen? Nitrogen, which was present in the ground state, will undergo into the excited state and it will emit the electrons. Okay. Now the excited state nitrogen, when it interact with the CO2, what it will make? It will excite the CO2 molecule and itself undergo the de-excitation, means in the ground state. Okay, so basically nitrogen is helping the CO2 molecule to undergo the excitation state. So here you can see that the electron excited nitrogen is present here. It undergo excitation and this excitation energy is transferred to the CO2. Once it get transferred, the CO2 will undergo higher excitation state, and once it will de-excite to the metastable state, it will emit the laser in the form of 10 to the power 6 micrometer. And once it will go to the ground state, another release of the photon will occur. Okay, so you can see that these are the possible laser transition E5 to E4, E5 to E4, transition E5 to E3. Okay, and the emitted for laser light will have 10 to the power 10.6 micrometer wavelength energy. So question may ask in the examination that what's the wavelength of the light emit from the CO2 laser and from the neodymium YAG laser. Okay. So this is production of the light. This is also as not as important. So this is how basically the CO2 discharge light looks like. Okay, you have this round thing. It is just like a gas pumping inside, and this is how it comes out from the gases inlet and formed in the XYZ stage, or whatever the treatment you want to do it. Okay, so here you can see in the images also the laser CO2 laser surgery is occurring. Okay, so what are the characteristic of this CO2 laser? It is a molecular gas. Okay, active medium CO2 and 2 helium. And pumping method that we use is a electric discharge. Okay, same only. Power output what we get is 10 kilowatt, which is lower than the neodymium laser. Okay, because it has a wavelength higher than the neodymium laser. So that's why the power output is lower for CO2 laser. Now, what are the various type of the CO2 lasers? So you can see that it has different kind of the laser present here: longitudinal flow laser, sealed off laser, high power diffusion cooled slab laser. So on for different technique, different kind of the laser has been already discovered. Okay. So drawbacks, what are the drawback of this CO2 laser? The heat action. Okay, the action of the laser can contaminate, can be affected by contamination of the oxygen or by carbon monoxide. Okay, and the reflecting plate may corrode. So these can also damage your eye if you are not properly treating this, if you are not using your laser properly. Okay, so next is basically the argon laser. Okay, argon laser is basically, we can say from the name only, the argon. Argon is a noble gas active medium. Okay. So the argon laser distinguishes itself by using the argon, and this is the scientist who developed this argon laser. His name is William Bridge. Okay. What it does, the argon is undergoing excited state in Ar plus 1 oxidation state, and it produces the light in the form of the green color. You can see this is the green color, and this wavelength range goes beyond ultraviolet and near infrared region. Okay, so this is like a more higher range of the wavelength you can obtain. Okay, so here also principal component will be same. So the argon basically laser made up of the bore or beryllia we say, that is barium oxide. Beryllium oxide basically it is made up of, and the same thing, cathode end well, anode connection will be there to electrically discharge your argon, to convert it into argon plus 1 oxidation state. So it is just electric discharge, mm, cathodic and the anodic power supply, plasma tube and resonator assembly. And these plasma tube basically made up of the beryllium oxide, which is capable of withstanding at very high temperature. Why it require high temperature? Because argon is a noble gas. To de-excite, to remove the electron from the argon, you need very high source of the energy. Then only it can undergo excitation. Okay, because its octet is complete now, and it is a noble inert gas. Okay, so the resonator assembly also consists of the two mirror, both at each end of the bore, and such that they are perpendicular to the length of the bore. Okay, so this is how basically it works. We don't have to go that much detail. Um, then principal component, it has like three part. First part consists of high reflector, filament. Filament are used here. That is a cathodic filament we can say. Then exhaust tube and cathode end bell are also embedded here for supporting the thermal and electrical connection. Okay. Then here's in the central joule part. So central joule part, as I told, it has a bore, that is a beryllium oxide, where argon gas discharge occur. Okay, why we are using beryllium oxide? Because it has high thermal conductivity and electrical insulation property. Okay, it has very high thermal conductivity and electrical insulation property. Then gas return hole help to circulate the ionized argon gas which are producing because of the electric discharge. Okay, then air flow is there indicating the direction of the cooling air. This is the airflow. Okay, to make it cool from outside. Then right side is having anodic region. Anodic region is the anode end well, anode connection, and the output coupler. Similar way, the cathodic, it has an anodic. Then this is the application. Okay, so application, if you see in the argon laser, mostly used in the photodynamic therapy. Okay, argon laser basically used in the photodynamic therapy. What is photodynamic therapy? We will study in the next class. Okay, so it has some photochemical reactions occur with the oxygen and undergo different kind of the reactivity in the form of radical state of the oxidation and then a peroxide and other thing, which we will study in the next class. Okay, so where it can used this kind of the laser. So this kind of the laser we can use in the bladder cancer. Okay, so if you have a bladder, in the bladder some cancer is there. So this kind of, here you can see in the figure also how the laser treatment is uh, evacuating your sorry, killing your cancer cells and making your bladder pipes open. So this is just an example of esophageal cancers. Okay, and here how basically they have done the treatment. It is just a biology process, but I'm just giving you the overview of this CO2 lasers where we can use in the uh, for the treatment of the bladder cancer. Okay. Also, you can see your laser application, CO2 laser application in gynecologist. Okay, gynecologist, as we all know that if we have some any cervical problems are related to the uterus or any other things, then we go for the gynecologist where there also you can have some cancers such as cervical intraepithelial neoplasia, which we call as a CIN. Okay, so it is just what it basically cause. It cause the abnormal cell growth on the surface of cervix. So this is the cervix you can see in the near to the uterus. Okay, that could potentially lead to the cervical cancer. Okay, so like cervical cancer means you will have abnormal growth of some of the tissues. Okay, so for removing that tissue, we can use the CO2 laser. So here you can see normal, it will look like this. Okay, and with the time what will happen, the increase in the tissue is a abnormal tissue growth is occurring. So this we call as a tumor or the cancers. So to remove this thing we use the CO2 lasers. Okay, and also endometriosis management. So this is the figure, you can see that here. This also in near to the uterus part only, that basically focus on managing the pain and infertility issue if occurring. Then you can also treat for the CO2 laser for ablating or removing this kind of the tissue near to the uterus. Okay. Then here also genital and vulvar lesion. Okay, so CO2 or diode laser, we can use it. So these all are the things we can use the CO2 in the improving of your urinary symptoms and improve the lubrication process. So what are the advantages of this laser use in gynecologist? Is the precision and minimum collateral tissue damage and reduce bleeding due to coagulative effect. Also, quick recovery time and shorter hospitality is will give and decrease the post-operative pain and scarring. So these are the advantage to use the laser in the gynecologist. Okay, so also it has an application in pulmonary medicine. Pulmonary medicine means like a breathing pipes. Okay, so breathing pipes where the from this bronchial the lungs is connected. Okay, so if you have a cancer of this, if for some other kind of the tissue has generated in your pulmonary pipes, so for to remove this also we can use the CO2 laser, central airway obstruction by malignant or benign tumor. So we can use a neodymium YAG laser also, diode laser, CO2 argon laser, all the lasers here we can use it. Okay. So the benefit, what is the benefit is that airway patency, immediate relief, it you will get it and can be combined with the stent placement. Okay. So these are the application. I will share you the slides, all the slides with you all. And here in the lungs cancer also, like a palliation, if it is occurring, so you have a background, you can see it cause. the lungs cancer, if anybody is having, there also you can use this kind of the laser. Okay. Then the control of hemoptysis, airway bleeding. Sometimes like people when it they cough, they get the blood during the coughing. Okay, so what's the reason behind that? They have basically hemoptysis. So why it basically occur? Because of the coagulation of the bleeding site in the airway mucosa. Near to the mucosa, they will have the some coagulation of the bleeding. Okay, and this also cause an example of tuberculosis. Tuberculosis are the inflammation. Okay, so what is the laser we can use in the this kind of airway bleeding? Here also you can use neodymium YAG laser for the deeper tissue penetration and hemostatic ability. Then advantage of the user, same. You will have the sharper, what? Good alternative to the surgery in high risk patients. So it can deeply penetrate also. But risks and limitation is the same for all the laser, I think, because the risks of airway fire in high oxygen environment, and and also require high skilled operator. Okay, high skilled operator, without that you cannot do it, and not curative for underlying the malignancy, mainly palliative disease. So also in the neurosurgery also, the laser interstitial thermal therapy we use. Okay, so basically brain tumor, if anyone is having the brain tumor, in that case also this kind of the laser interstitial thermal therapy we use to remove the tissues from the, if it is depositing in our brain. Okay, then epilepsy surgery, if some of the tissue has grown up in our legs and cause the disease is spreading across the legs, in that case also you can use the laser, particularly CO2 or the neodymium YAG laser basically you can use. Okay, so these are the applications of the laser where you can get the treatment from the laser. Okay, so ophthalmology also, like this you already know, cornea treatment or the cataract removal such as glaucoma treatment if you have to do. In that case also diode laser, neodymium YAG laser, argon laser, and selective laser you can use. Okay. So LASIK, laser assisted in situ keratomycosis. Okay. So these laser provide basically femtosecond transition. Okay, very fast. So these kind of the vision correction. Uh, in the basically what I have seen during the dentist, when we are going for the dentist, as well as the surgery, and mostly in the eye surgery, the laser is the best method I think people are using. For other things, it is you need very high skilled operator, I will say. Otherwise, for this treatment, for this kind of the treatment, the laser is mostly important. Then here, so in the neurosurgery, what kind of the laser you can use? Neodymium YAG CO2 diode. In ophthalmology, excimer and neodymium YAG. Here also argon laser also you can use, and their basic treatments for the for what treatment you can use this kind of the laser is given. Then here this is very important and conclusive slides. Okay, so here it is the description of everything where you have a laser type. Okay, gynecologist, pulmonary neurosurgery, dermatologist, ophthalmology, where you can use CO2 laser, where you can use neodymium YAG laser, diode laser, excimer laser, femtosecond laser, and the argon laser. Okay, all are mentioned here. Okay, then we will in the next class we will read about what is photodynamic theory. Okay, so for today I think this much is fine. I have to take the attendance also. Uh, okay, so